Hello, folks. So today we have a snow day with no school, or delayed opening. So I'm preparing your online lesson, which would have been today's class lesson, and it's going to be a review for the final exam. And so rather than giving you a hard copy practice exam, I will just go over each problem that'll be slightly different than the actual exam, but every type of problem that's on the exam as it will appear on the exam. So this lesson should help you prepare. So here we go. So we're going to start with the first problem, which is find the average rate of change of the function over the interval, and we're going to solve without a calculator, and you need to show all your work, and that helps me to give you partial credit if the final answer is not quite right. So let's start with the function f of x, and f of x is equal to x squared, and we want the average rate of the function on the interval from x equals 1 to x equals 2. Well, the formula for the average rate of change, and that would be f, and that would be the change in f with respect to the change in x, and this is average. So the average rate of change on an interval would be f of b minus f of a over b minus a. So this is what we need to do, is we need to find f of 2 minus f of 1 all over 2 minus 1. Well, since f of x is x squared, it would be 2 squared minus 1 squared over 2 minus 1, which is 1. And that's, of course, 4 minus 1 over 1, and our answer is 3. So the average rate of change for x squared on an interval from 1 to 2 is 3. So I'm going to number these problems. This will be problem number 1. And let's move on to problem number 2. In this problem, we're going to find the slope of the curve at the given point P, and then find the equation for the tangent line at P. So let's start by finding the slope. So the slope, m, and that's at point P, is equal to y prime, the derivative of y at point P. And the derivative of y, you can see that is 6x squared. And this is at point P, or at x is equal to 1. So if we plug in a 1, we have 6 times 1 squared, and so our slope is 6. So this is our slope. So let's put a little brace here. That's the first part of our answer. We found the slope of our curve. So now we want to find the tangent line. Well, since we have the point 1, 2, and we have the slope 6, we can use our point slope form. So I'm changing my font color. This is the second part of the problem, where we say y minus the y1 from our point is equal to the slope times x minus the x1 from our point. So we're going to plug in the 1 and the 2 for our x and our y, and a 6 for m, our slope. And I'll go back to black here. And I get y minus y1 is 2 is equal to our slope, which is 6, times x minus x1 is 1. Now let's put this in y equals mx plus b form. So distributing the 6, we get 6x minus 6 on the right. And if I add 2 to both the left and the right hand side of the equation, I get y is equal to 6x minus 4. So here's my final answer. This is the equation for the tangent line. And of course, the initial part of the problem was finding the slope. So there we have it. We have our slope, which is 6, and our tangent line, y equals 6x minus 4. In this problem, we're going to find the limit if it exists. Now we want to do this without a calculator and show our work. So in this case, let me change my font color to blue. And what I want to do is I want to remember, and I'm hoping you remember, that the limit as x goes to 0 of the sine of x over x is 1. So we want to change this a little bit so that this looks like similar to what we have here. And we do this by having it be the limit as the sine of 2x. So we want there to be a 2x in the denominator. And so we can do this by multiplying the bottom by 2, but we can't multiply the bottom by 2 unless we multiply the top by 2, because we know that 2 divided by 2, they cancel out. So we don't change the value if we multiply both the top and the bottom by 2. However, we change what we have here, because as x goes to 0, 2x also goes to 0. So now we can solve our problem. I'm going to go back to black, and we end up with a 2 in front. I'm going to factor that 2 out that's in front of the sign and say the limit as x goes to 0, which is the same as 2x going to 0, of the sine of 2x over 2x is equal to 2 times, and of course this limit right here is equal to 1 because of this, so it's 2 times 1, and our answer is 2. In this lesson, we're going to find y prime when y is equal to cosine cubed of the natural log of x squared. And we can see that this is a composite function, so we're going to need the chain rule. So we're going to take the derivative of the entire function, and I'm going to write this as the cosine of the natural log of x squared. And this entire thing is cubed because it is being cubed. This is a different way of writing the same thing. But here you can see the composite better. So we're taking the derivative with respect to the cosine of the natural log of x squared, because the outer function is the cube. And now we're taking the derivative of the cosine of the natural log of x squared with respect to the natural log of x squared, and here our next function in our composite is the cosine function. And now we take the derivative of the natural log of x squared with respect to x squared, and here our outer function here is the log function. And now we take the derivative of x squared with respect to x. So let's work this out. So our first piece right here, the derivative of this entire thing cubed, means that we're going to have to bring down the 3. So 3 times the cosine. So the cosine of the natural log of x squared is going to be now all raised to the second degree, and we can put that here. And this is multiplied by the derivative of the cosine is the negative sign, so it's a negative sine of the natural log of x squared times the derivative of the natural log is 1 over its input, which is x squared, and then lastly the derivative of x squared is 2x. So we have to work out what this is equal to. Now I'm going to go into red because we can see that this x right here cancels out with one of these x's, and of course this negative sign can be moved to this negative sign that we see here can be moved to the front. And let's work this out. What do we end up with? We end up with the 2. Let's take let me mark these. I'm going to take this 2, the negative sign, and the 3, and multiply them together. So that's going to give me a negative 6. And that's the 3 times a negative times a 2. And then we have an x on the bottom. and that x on the bottom is right here. And now we're going to multiply these two pieces together, and we get times the cosine squared of the natural log of x squared times the sine of the natural log of x squared. And this is as simplified as we can get it, so I'm going to put a box around. This is our final answer. And in this problem, we were demonstrating our knowledge of the chain rule when taking the derivative of the composite of multiple functions. In this problem, we're going to find the numbers a and b, which are constants, such that f is continuous in its domain. So I'm going to use the blue font here. Okay, so we know that at x equals 0, y is 4. Well, that's our y-intercept. So whenever x is 0, the value of y is our y-intercept. So b is our y-intercept. So we know right away that b is going to equal 4. So now we'll say, okay, then y equals ax plus b, which is 4, is going to have a height of 8 when x is 2. So we would say that a times 2 plus 4 equals 8. If I subtract 4 from both sides, I have 2 times a is equal to 4, and divide by 2, a is 2. So here's my answer. If b is equal to 4 and a is equal to 2, for this expression here, for this function here, our a and our b, then our function f of x will be continuous.